Alright guys, how's it going? So we've been looking at physical and chemical changes and a little bit of physical chemical properties, but we often get the two um, mismatched, right? So let's look at, more importantly, how would you know whether a characteristic of a substance was a physical or a chemical property? Well, first off, when we're looking at a physical property of a substance or a chemical property, we're looking at one substance. We're not analyzing how it's reacting with something else. We're just looking at one specific thing. We're not. If we were looking at lead nitrate and potassium iodide, you know, we're not looking at the precipitate that it makes when they react. We're just looking at one chemical. So we'd just be focusing on the lead nitrate, or we'd just be focusing on the potassium iodide. Okay, so a physical property is any property that describes a physical characteristic of a substance and not how the substance behaves chemically. So let's take an example of uh, maybe a substance malleability. Now, malleability is just the able to be um, hit and beat into a specific shape, such as this aluminum is actually, you could hit it with a hammer and get it into a fine piece of aluminum, a thin strip of aluminum. Then we have ductility. So if an object is ductile, it's able to be put into a long wire. So it's able to be stretched and actually put into the shape of a wire and not break, not be brittle. Something like this would be like copper wiring. Another thing would be boiling point. So when we look at boiling point or melting point, condensation point, freezing point, point of sublimation, any of those points, we're looking at it changing phase, but we're not looking at it changing into a different substance. So if we boil water at 212 degrees Fahrenheit or 100 degrees Celsius, um, even if it goes from liquid water to water vapor, it's still, H2O, dihydrogen monoxide. It hasn't changed its identity. Um, a frequency is the number of times that a specific wavelength is hit per second. Um, so that has nothing to do with any kind of chemical reaction. Now you have viscosity. Viscosity is something that if we define something as viscous, say we say that honey is more viscous than water, it's its resistance to flow. So rather than covering a large surface area, it's covering a lesser surface area because its resistance to change its flow state. Something solubility. A lot of times people think that solubility, such as if salt is soluble in water, that it's actually creating a chemical reaction when in turn it's just dissolving and maybe the ions are going to dissociate, but you still have salt at its original component. It hasn't bonded to make a different compound. It's still salt, it's just dissolved in the substance and the solvent or the solution, whichever it is. So let's take a look at chemical properties. What makes these a little different? Well, chemical properties are properties of a substance that describe how a substance chemical composition will change given a specific set of conditions. So this is how we're looking at how it's going to go from one substance to another if you give it a set of conditions. So, so something that is, let's take something that's radioactive. We're going to look at how the nucleus of a element is going to change given a certain set of conditions because it's an unstable form of ion or isotope. If we're looking at the flammability of an object, we're talking about, hey, how combustible is it? Such as the flammability of ethanol or methanol. If we look at something's, if it's an oxidizer, right, we're talking about, hey, is this a reducing agent? Is this something that's more likely to steal electrons from another substance? Something that's corrosive, right? Like if a metal's left out to rust, is it going to be forming a metal oxide in the outside coat because it was exposed to air for a long period of time? Um, if we're looking at something that's pyrophoric, that's its ability to, or its high chance of reacting with air. You know, we look at pyrophorics like zinc, right? It's what makes fireworks. So this is anything where the chemical composition is actually going to change. When we talk about physical properties, those substances, they're not changing. They might take a different shape or form or state of matter, but they are still the same substance. So let's look at a few of these, okay? So freezing point. Would you say that's a physical or chemical property? Well, freezing point is a physical property, because even when water goes from liquid water to ice, it's still, you know, dihydrogen monoxide. Okay, combustible. Okay, well, if something's combustible, that means it is reacting with air, and it is a chemical property. Let's see if something's water reactive. Okay, so if something is water reactive, this is a chemical property. If I throw sodium in water, and I'm talking pure sodium, not salt, not sodium chloride, but pure sodium, it's going to explode. It's going to catch fire and then explode. But something that's water reactive, that's a chemical property. We're seeing how it's reacting with the water. The reactive word should have gave it away. Okay, viscous. Remember this resistance to flow. It's same substance, but it's still resistant in its own individual form. It's exact substance, which is a physical property. Okay, whether something's toxic. If something's toxic, that's how it's reacting chemically to your body. Melting point. Okay, melting point. That is a physical, I almost trying to write chemical, physical property. It's changing states, going from a solid to a liquid. Pyrophoric. We just saw this one, right? This is a chemical property. It's reacting with air. Okay, if something's corrosive, we're forming that metal oxide. That's a chemical property. Condensation point. Okay, this is going from a gas to a liquid. Okay, so this is a physical property. And finally, ductility. Remember, this is the ability to be put into the form of a wire or a long, not brittle form, something like a wire. This is a physical property. So these are just a few examples, guys. Hope this helped you out. Have a good day.